Hello guys, welcome to my channel Engineer Star. In this video I will discuss all the numericals and theory which was asked at Purvanchal University uh, of the chapter Statistical Hydrology. It is also useful for other university. The first question that was asked in Purvanchal University 2022 is what is return period, frequency and risks. First is return period. Return period of a flood. In statistical hydrology we deal with flood. Return period of a flood of a given magnitude can be defined as the average interval between the occurrence of the flood equaling or exceeding the given magnitude. It is the average interval. If this is the interval, then it is the average of all interval between the occurrence of flood equaling or exceeding certain magnitude. If the magnitude is x, then which is equaling or exceeding the given magnitude. For example, 50 years flood means that the flood equaling or greater than the specified magnitude can occur on average once every 50 years. After 50 years it will repeat on average. Next is this frequency. Flood frequency is a measure of how often a particular flood magnitude or discharge occurs within a given period. That means in a given period, how often or how many times that 2 times, 3 times, 5 times, 10 times particular flood of magnitude, let's say x, will occur within a given period from this to this period. It is often expressed as a reciprocal of the return period. Return period is t, so the frequency is 1 divided by this return period. In physics we have also learned that frequency of wave is 1 upon time taken. So here frequency of flood is 1 upon this return period. It is similar to the physics. And the risks. We know that risk is a measure of a potential adverse consequences or impact associated with a particular flood event. If this is a flood, then risk is a measure of potential adverse consequences. The consequences means effect or impact of that particular flood. It considers both probability of the flood occurring and the vulnerability or exposure of the affected area or asset. Both probability means how often the flood will occur, and vulnerability means its impact to the society, human beings. And risk assessment takes into account factors such as first of all, let me erase. Risk assessment takes into account factors such as potential damage to the infrastructure, property and human life, as well as economical and environmental impact. Risk assessment is the examination of risks. It takes into account factors such as, for risk examination, we have to study the potential damage to the infrastructure, human life, property, its socio-economic impact, etc. And the next question that was asked in 2021 of Purvanchal University is, write short notes on probability of exceedance and return period. First is probability of exceedance. Probability, in other words, in simple words, it is a chance over a given time period. This is the time interval, given time period, that a flood, let's say it is a flood, that a flood will reach or exceed or specific magnitude. That is the probability. What is the probability of that flood to equal or exceed some magnitude? The magnitude of flood is discharge, let's say 1000 meter cube per second. Then probability of exceedance is a chance over a given time period. For example, 100 years, 100 years, that a flood will reach or exceed. Reach means 1000 meter cube per second, and exceed means more than 1000. This is also called probability of occurrence. So probability of exceedance is also called sometimes called probability of occurrence. Let's say the value P is the exceedance probability in any given year. P value will be like 0.5, 0.3, 0.4, between 0 and 1. The exceedance probability may be formulated simply as the inverse of return period. Inverse of return period T. For example, for 2-year return period, if the return period is 2, the probability of exceedance in any given year is this, and this equals 1/2 is 0.5. To convert it in percentage, we multiply by 100. 0.5 into 100 is 50%. In formula, exceedance probability is 1 minus 1 minus P power n. And next is return period. Return period of a flood of a given magnitude can be defined as the average interval between the occurrence of flood equaling or exceeding the given magnitude. I have taken the example of 1000 meter cube per second. This is a discharge. Return period of a flood of a given magnitude. This given magnitude can be defined as average interval. This is the average interval of time of a given magnitude between the occurrence of flood equaling or exceeding the given magnitude. For example, one flood occur in year, let's say year 2000. In the year 2000, then this 1000 or greater than 1000, equaling or exceeding 1000, occurs in the year, let's say 2023. then this interval from 2000 to 2023, it is called return period. Example of 50-year flood means 50 means 2050. For example of 50 years flood means the flood equal or exceeding a specified magnitude, this is also example, can occur and average once every 50 years. The 50 years is the average. It may come before 50 years or after 50 years. So in 2015 Purvanchal University, this is the similar question. Here we need to write short note, but I have written long note, so you can read this, pause the video and read this, or write or take a screenshot. This is a short note asking 4 marks, so you can summarize in your own language. So I will just read it for you. Return period. The return period, also known as recurrence interval or exceedance probability, is a concept. Return period is also called recurrent interval, or return interval is a concept using statistical hydrology and other field to quantify the likelihood of a specific event occurring within a given frame. Quantify is the number, is the amount, the likelihood of a specific event means, for example, flood, landslide occurring within a given time frame. From the given time frame, in the concept of flood, the return period provides an estimate of how often a flood event of a particular magnitude or discharge is expected to happen on average. An estimate, it is not exact, but it is the estimate of how often, how many times a flood event of particular magnitude is expected to happen. It is thus on average. To understand the return period, let's consider an example. Suppose we have a data set of historical annual maximum flood discharge for a river. Each data point represents the highest discharge recorded in a given year. For example, we have the data of 2000, 2001, 2002, 3, 4, like that. Each data point represents the highest discharge recorded. The maximum value of discharge recorded in particular year. Now, let's say you sort this discharge in descending order. From highest to lowest. That means 1000 and in 999, 997, 992.1. So this is the example in descending order from highest to lowest. The return period is calculated by dividing the total number of years, let's say 50 years, or even more. The return period is calculated by dividing total number of years in the dataset by rank of a specific flood event. This is rank 1, this is 2, 3, 4, like that. So 50 for this flood, it is 50 by 1, and for this it is 50 by 3. Rank of specific flood event. The rank refers to the position of a flood event within the sorted list of this chart. For instance, if the flood event has a rank of 5, 1, 2, 3, 4, and let's say 990.9, this is the 1, 2, 3, 4, this is the rank 5. For example, if a flood event has a rank of 5, it means that it is the 5th highest flood discharge in the dataset. Yes, it is the 5th highest. The formula for calculating the return period is RP is n plus 1 divided by rank. RP is return period, and n is total number of years in data 6, and R is rank. So RP is n is the total number of years, for example 50, and divide 50 plus 1, that is 51, divided by R is the rank 5. Then (50 plus 1 divided by 5) is 10.2 years, and if the data is like n is 99, and this discharge got rank 5, then it will be 99 plus 1, that is 100, divided by 5 is 20 years return period, and similar. The return period is often expressed in years. It is not usually expressed in minutes, second, hours, dates. It is often expressed in years, indicating the average time between occurrence of flood of equal or greater magnitude. For example, if calculated return period for a flood event is 50, it suggests that on average a flood of that magnitude is expected to occur once 50 years. If that flood of magnitude of some magnitude occurs in like 2022, then it's expected for that magnitude to occur 22 plus 50. 2022 plus 50, that is 2072. It is expected to occur in 2072, but it is not exact. It may be earlier than this or slightly higher than this. It's important to note that the return period represents a statistical average and does not guarantee that a flood of a specific magnitude will occur precisely at the expected time. That means if the flood occurs in this 2022, that means it is just the 50 years is just an average. That means It does not guarantee that it must come in 2072. It does not guarantee. So it simply provides a probabilistic estimate based on historical data, because this flood of this magnitude had occurred 50 years before 2022. This is average. In average, it had occurs like 97 to 72 around. And return period are commonly used in flood risk assessment, flood plain zoning, designing infrastructure, for the examination of risks, and to separate the area of flood, and designing infrastructure, mainly hydraulic infrastructure such as dams, spillway, bridges, culvert, etc. They help engineers and planners, designers make informed decisions by considering the potential frequency and severity of flood in a given area. Frequency means how many times it occurs, and severity means frequency means how many times, that is quantity, and severity means like quality, or like its magnitude of the flood. Next question that was asked in Tribhuvan University 2078 Vadra. Define the term exceedance probability recurrence interval. This I have already explained, and recurrence interval also I have already explained. Exceedance probability is also called probability of occurrence. So there is probability. So probability is nothing but chance over a given time period that a flood will reach or exceed a specific magnitude. This is called probability of occurrence, or the exceedance probability. Let's say value P, the value of probability is P, is denoted by P, is the exceedance probability in any given year. The exceedance probability may be formulated simply as the inverse of the return period. It is the reciprocal or inverse of the return period. Return period is, let it denote by T. Then for example, for a 2-year return period, for T it is 2, so the exceedance probability in any given year is 1/2, that is 1/2, or 0.5 or 50%. If for let's say 5-year return period, this will be 5, and 1/5 is 0.2, or 20% in a given year. That means if the flood has return period of this 5 years, then that magnitude occurs in 5 years interval, but it doesn't mean that it will not occur in between this. But in a given year, the chance or probability is only 0.2% for this time period. Next is recurrence interval. Recurrence interval describes the frequency on average at which specific type of event occur. In hydrology, recurrent interval can be developed for stream flow, or precipitation. Next is frequency factor. Frequency factor is used to compare and relate results and attach probabilities to several sets of maximum rainfall data. K is primarily it is frequency factor is denoted by K. K is primarily a function of a recurrence interval for a particular. This frequency factor is the function of, that means it depends on recurrence interval. For a particular probability distribution. This question was asked in Tribhuvan University, TU 2009. Asad, define flood. Define design flood. Design flood means the flood adopted for a design of hydraulic structure such as bridge, spillway, culvert, dam. So is the flood adopted for this particular structure. What magnitude of discharge or what flood is adopted for the design, that is the design flood. It is the maximum flood that any structure can safely pass. So that means up to this magnitude the structure will safely pass, and above it may fail. Design flood is also known as inflow design flood. Return period I have already described. The return period of an event of a given magnitude may be defined as the average recurrence interval between the event equaling or exceeding a particular magnitude. What is risk? Risk is defined as the probability of occurrence of the event at least once over a period of n successive years. At n successive years, what is the probability of occurrence? That is the risk. Flood frequency. The frequency of flood. Flood frequency is the concept of probable frequency of occurrence of a given flood. For example, it is not sufficient to say that the maximum observed flow was 1000 meter cube. It is also necessary to say what is the frequency of occurrence of this flood. This was the theory portion. Now I will discuss some numerical problems. I will focus on Purbanchal University, which is also useful for Tribhuvan, Pokhara, Kathmandu University, and all university. The regression analysis for 30 years flood data. We have the flood data of 30 years. So n is 30 at a point. If there is river, then we have measured discharge at this point, certain point on a river, yielding sample mean of 1200 meter cube per second and sample standard deviation 600 meter cube per second. We have used the term sample because we have only 30 years data. We have not the data of whole. So population is the whole data, but in practical it is hard to find the data of whole. So we have taken only 30. So it is the 30 is the sample of this whole population. So we have calculated sample mean and sample standard deviation. So sample mean is denoted by x bar and standard deviation is denoted by s or sigma n minus 1, which are 1200 and 650 respectively. For what discharge would you design a structure let's say there is some structure over here. Let's say this is a structure. For what discharge, the mean discharge is this, and deviation, standard deviation discharge is this. For what discharge would you design a structure to provide 95% assurance? 95%, that is 0.95. The structure will not fail. We cannot say that 100% the structure would not fail, but can say that for 95%, we have to find that discharge that provide 95% assurance in the next 50 years. So life period will be 50 years, and use Gumbel's method. The value of mean and standard deviation of reduced barrier, mean reduced barrier is limited by y bar yon, and standard deviation of reduced barrier is denoted by s yon. Y yon bar and s yon, whose value was 0.53622 and 1.11238. Since assurance is given, then risk is the opposite of assurance, so it is 5%, because 100% minus 95% is 5%, which is 0.05. So first of all, we need to calculate the risk, which is 1 minus p yon, and the risk is 0.05. 1 minus 1 minus this p is, I have discussed in theory, 1 by t, and t is 50, because we have to check it in 50 years, and by calculator we can find t 975.3 years. So mean of this is the given, and this is by using this formula. Yt is minus ln ln t by t minus 1. Yt is minus ln ln t is this 975.3 divided by 975.3 minus 1, that is 6.8822, and the formula of kt is yt minus yn divided by sn. Yt is 6.8822 minus yon bar is 0.53622, and sn is 1.11238. so kt is this. So by this formula we get the value of this. So the main formula is for this chapter is x t is x bar plus k times standard deviation this is the discharge for written period of t. This is mean, this is standard deviation, and this is k. The kt is given by yt minus yon bar divided by sn, and this yt is again given by yt is minus ln t divided by t minus 1 and sigma n minus 1 is sample standard deviation x minus x bar square summation divided by n minus 1. Don't be confused by this minus 1 because if for the population standard deviation it is summation x minus mu square divided by n. This is for since here is n, so here is n, and since here is n minus 1, here is n minus 1. This is the population standard deviation, and this is sample standard deviation. The difference between when to use these two is this is for whole population. If we have the data of whole population, then only we should use this, but in practical to determine the flood in particular year we don't have the infinite data of all the year. We only have the sample data of year, so we must use this sample standard deviation. So we need to write minus here, subtract 1 from this year. So these are the main formula used in this chapter, Statistical Hydrology. So 4908.25 I would design the structure for the distance of 4908. For 95% of assurance, for what distance would you design? I will design, or we would design for this discharge, 4908.25 meter cube per second. If we design for more discharge, then it will be uneconomical, and if we design for less design that of this, then there is a risk of failure. And this question was asked in Purvanchal University 2021. Following are the yearly maximum discharge. So year wise, so yearly maximum discharge in 1977 the maximum discharge was 2140 meter cube per second. In this year 1978 the maximum discharge was 2130 and so on. Of Tholdaga hydrological station of Humla, Karnali of Nepal. So these are the given data. First we need to add all these discharges. So summation x is 48675. By counting this, the number of year was 30, so mean is this total divided by number of year, that is 30. So mean discharge is 1622.5 meter cube per second. So x minus x bar, x is 2140 minus x bar is 1622.5 and square, and 2130 minus 1622.5 square, and similarly 1890 minus 1622.5 square. Since we have square, so all the value will be positive, and we add all of them and found summation x minus x bar square is 7130645.5 meter cube per second. So standard deviation, this is the sample span standard deviation, so we need to deduct minus 1 from yon, so it is root under summation x minus x, this is bar square divided by n minus 1, so standard deviation is 495.8672. The unit of discharge is meter cube per second. So in question we have given this year and discharge, and we have to determine the peak flood for 50, 100 and 200 year return period by Gumbel method. So the discharge peak flood for the flood of return period 50, flood of return period 100, and the flood of return period 200 by Gumbel method. Reduce mean and reduce standard deviation, that is reduce mean is y1 bar and reduce standard deviation is Sn, that is 1.112. So we need to calculate x50 for 50 year return period, 100 year return period, 200 year return period. We have to calculate the magnitude of discharge. So we know this is the main formula. Xt is x bar plus kt and standard deviation. So this and this value will be same for all the cases, that is this and this, and the variable is this k50 for 50 year return period, k100 for 100 year return period, and k200 for 200 year return period. So we need to find this. So the formula of kt is yt minus yn bar divided by Sn, where yn and Sn are constant for the given data series. Its value is given in question, and y50 is minus ln t by t minus 1. T is this, so 50 by 50 minus 1, 100 by 100 minus 1, 200 by 200 minus 1. By calculator we get the value of y. So by substituting the value of this 3y in this equation, we get for 50 years k is, and for 100 years k is, and for 200 years return period k is. These two will be same for all, and y50, y100, y200 we have already calculated. So y1 is 0.536, y1 is 0.536, that is mean this standard deviation is 1.112 and 0.536. So K50, K100, K200 value we can calculate, and from equation first, we can find Yox50, Yox100 and Yox200 as by this formula. This mean and standard deviation is constant for all three cases, and this is K value 3.0269, 3.6548, 4.2804. Therefore, peak flood for 50, 100 and 200 years return period are this 3123, 3434 and 3745.01 meter cube per second respectively. This is the first part. And in next part, compute 90% confidence limit for about flood using FC value is given 1.649. For 90% confidence limit, and with this FC value 1.645 for Yox50, we calculate B by formula 1 root under 1 plus 1.3 K plus 1.1 K square, and for 50 K is 3.0269, 3.0269. So B is 3.8747 and SC is B standard deviation root under N. So it will be 350.7865. Yox1 and Yox2 is 550 plus minus Yox-C, Yox-E. Yox50 is 3123 plus minus Yox-C is given in question 1.645, and Yox-C we have just calculated 350. So for this discharge and for 90% confidence limit, the maximum value is 9700 and the minimum is 3700 and 2546 meter cube per second. And the next for Yox100, this is the same formula. B is root under 1 plus 1.3 K plus 1.1 K square, and K value for 100, that is K100 is 3.6548, and Yox-C is B sigma N minus 1 by root under N, and Yox12 is Yox100 plus minus Yox-C, Yox-E. So this is the range. And for Yox200, B is 1 plus 1.3 K plus 1.1 K square. K is for 200 4.2804, so we can calculate B. Yox-C is B sigma N minus 1 divided by root N, and Yox12 is Yox200 plus minus Yox-C into Yox-E. So by taking positive sign, x1 is this, and taking negative sign, x2 is this. This was the question asked in 2019. Given the following record of maximum yearly peak flood for 10 years in a gauging station: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maximum discharge in year 1 is 300, in year 2 is 700, third year is 200, and so on. Take values of reduced mean and reduced standard deviation in Gumbel's extreme value distribution, as this is reduced mean is y1 bar as 0.4952 and Sn is 0. This is given. Sn is 0.9496. What is the probability of exceedance of flood of magnitude 2000 meter cube per second? What is probability that this flood may occur in the next 100 years? First, we have to calculate what is the probability of exceedance of flood of magnitude 2000 meter cube per second. So, 10-year data is given, 300, 700, and so on. So, by adding this, we get 500, 5500, and this divided by 10 is 550. So this is yoks 300 minus 550 square, that is 62500, and for this 700 minus x bar 550 square, that is 22500, and so on. And by adding this all, we get 82500, and the standard deviation is redundant summation x minus x bar square divided by n minus 1. So 82500 divided by 10 minus 1, it is 302.765 meter cube per second. And this is the given in question. And for design flood of 2000 meter cube per second, xt is x bar plus kt sigma x or sigma n minus 1. It is the formula. Xt, the design flood is this, and this we have already calculated, so kt will be this. And again we know that kt is yt minus yn bar divided by Sn, and these two values given in question, so we can calculate yt. But in question we have asked probability of exceedance. Probability of exceedance is 1 upon t. So first of all we need to calculate t. To calculate the t, we have this formula: yt is minus ln t by t minus 1. So yt is 5.043, so it is equal to minus ln t by t minus 1. By calculator we get 155.43, which is nearly equal to 156. This is the written period. Bulk probability of occurrence is reciprocal, that is 1 over t. So it is 1 over 156, that is 0.00641. To convert in percentage, multiply by 100, so it is 0.641 percentage. This is the first part of the question. And next part is what is the probability that this flood may occur in the next 100 years? This flood means this 2000 meter cube per second flood to occur in 100 years. Next, to occur in next 100 years. So probability of flood of magnitude this occurring at least once in 100 years, that is next 100 years, is 1 minus 1 by p power n. 1 minus 1 by p is this 0.0041 power this 100 years, so it is 0.474, it is 47.4%. And the final part is, what are 80% confidence limits of about flood this 2000 flood if FC is 1.282? For this, first of all, we need this formula. B is equal to under root 1 plus 1.3 k plus 1.1 k square. We have already calculated k 4.7892, so B is this, and SC is B root on B sigma n minus 1 divided by root under n, so it is 545.446. X12 is for 80% confidence, FC is for 80% confidence limit, FC is 1.282, and this is given, and SE is this, so X1 taking positive sign, X1 is 2699.262, and taking negative sign, X2 is 1300.738 meter cube per second. This was the question asked. The question is, estimate peak flood at Barrage using Gumbel method for two different return periods. In Barrage, for return period of 100, peak discharge is 500 qmax, and for 50 it is 400 qmax. This is the question, and we have to estimate the flood discharge for the barrage for return period of 500 and 1000 years. So for 50 years and 100 years, it is for 50 years discharge is 400, and for 100 years discharge is 500. So we have to calculate discharge at this 500 and 1000 years, and this is the basic formula. Xt is x bar plus kt sigma n minus 1, and for T50 it is x50 is x bar plus k50 sigma n minus 1, and for return period 100 it is x bar plus k100 sigma n minus 1. By subtracting first from equation second, x 100 minus x 50 is this, and this minus this is 0, so this minus this sigma n minus 1 will be common, and k100 minus k50, x 100 is 500 and x 50 is 400. 500 minus 400 is 100. It's equal to k 100 minus k 50 times sigma n minus 1, and the formula of kt is yt minus yn bar divided by sn. For 100, k 100 is y100 minus yn bar divided by sn, and for written period 50, K50 is Y50 minus Y1 bar divided by SN. So this minus this, K100 minus K50 is 1 by SN, get common, so this minus this, so plus and minus Y1 bar cancels, so Y100 minus Y50 is the remaining. To calculate Y100 and Y50, Y100 is minus ln T by T minus 1, which is 100 by 100 minus 1, so it is 4.60015. Y50 is minus ln T minus T minus 1, this 50 by 50 minus 1, it is 3.90194. Equation 3 becomes Y100 minus Y50. Y100 is this minus Y50 is this into sigma n minus 1 into sigma n minus 1 is equal to 100. Equation 3 is K100 minus K50. K100 minus K50 is this Y100 minus Y50 divided by SN, so divided by this minus this divided by SN, so sigma n minus 1 and SN will remain here, and here will be 100 divided by 4.60015 minus 3.90194, it will be 143.2234. So we need to calculate for 500 and 1000. For a 500, Y500 is minus ln 500 divided by 500 minus 1, it is 6.21361, and for 1000 it is minus ln T by T minus 1, that is for T1000 it is 1000 by 1000 minus 1, that is 6.90726. And this Y500 minus 500 into sigma n minus 1 SN is X500 minus X100. By this similar process we can write this, and X500 will be 732 meter cube per second, and this Y1000 minus Y100 by this formula, X1000 is 830.432, which is nearly equal to 831 meter cube per second. So peak flood at Kosi Barrack for written period 500 and 1000 is this and this meter cube per second respectively. This question was asked in 2017 using 30 years data. We have been given a data of 30 years and Gumbel's method. Find the flood magnitude for written period 150 years for a river are found to be this and this. For written period this, discharge is this, and the return period this, flood discharge is this respectively, where in this we have to calculate this mean and standard deviation. The mean is x bar and standard deviation is sigma n minus 1. Take values of reduced mean, that is y1 bar is for n is equal to 30, this is this, and Sn standard deviation is this. So we know kt is yt minus yn bar divided by Sn, and yt is minus ln t by t minus 1 for this 150. For 100, put 100 in place of t, and for 50, for t equal 50, so t equal 50. So from this formula, y100 is y100 is y100 minus yn bar divided by Sn. y100 is 4.6 minus yn, and Sn value is given in the question, this and this. So we can calculate k100 and k50, and this is the basic formula for t equal to 100. This k100 is 3.653, and for x50 is 1060. x50 is 1060, and k50 is 3.026, and here is 2 unknown and 2 equation, so we can solve by calculator or any method. Then we got the value of x bar, that is mean is 384.338, and standard deviation sigma n minus 1 is 223.285 meter cube per second. Next question is estimate the magnitude of flood for return period t, and t is 500. So we need to calculate x 500. For 500, y 500 is minus ln this 500 divided by this 500 minus 1 is this, so y 500 is k 500 is y 500 minus this and this given in question, so it will be this, and by this formula and this and this we have already calculated, and k 500 we have just calculated 5.1037. we can calculate x 500 as 1523.918 meter cube per second. And third is what are the 95% and 80% confidence limit for this? If f 95 is 1.96 and f value for 80% confidence limit is 1.27, so we need to find the limit or interval, that is x1 and x2 for both 95 and 80% confidence limit. So for 95 it is 1.92 and 80 1.28, 1.96 and 1.28. 1.96 and 1.28 for 95 and 80% respectively. First of all, we need to calculate B. B is root under 1 plus 1.3 k plus 1.1 k square, and k is 5.1037. So B is 6.024. C is B 6.024, and sigma was 223.285, and yon was yon is the data number of years, that is 30 years data, so yon is 30. So SC is 245.571, and for x1 and x2 for confidence limit, it is x 500 plus minus FC. FC is we have already taken from question, and this we have already calculated. X 500 was 1523, and SC was 245.571. So for 95% confidence limit, x1 and x2 are this, and for 80% confidence limits taking positive sign, x1 is 1830.249, and taking negative sign, x2 is 1209.587 meter cube per second. This was asked in 2016 5B in 8 marks. The flood frequency for a stream has been found to be as follows. For written period 10, peak discharge is 109, and 244 peak discharge for written period 200. Estimate the peak discharge for written period 400 years and 5 years by using Gumbel method. So given is for x 10 peak discharge is 109, and for written period 200 the peak discharge is 244, and we need to calculate the peak discharge at 400 and 5 written period. So this is the formula. X3 is x bar plus kt sigma n minus 1. For 10, x10 is x bar plus k10 sigma n minus 1. x200 is x bar plus k200 sigma n minus 1. This minus this, x200 minus x10 is this minus this is 0, plus this will be common, so k200 minus k10. So x200 is given 244, and similarly x10 is 109. So the formula of kt is kt is yt minus yn bar divided by sn. K10 is y10 minus yn bar divided by sn. K200 is y200 minus yn bar divided by sn. This minus this, so 1 by sn will be common, so this minus this will cancel, so y200 minus y10. y200 is minus ln this 200 by 200 minus 1, and yt is minus ln t by t minus 1. Here t is 10, so 10 by 10 minus 1. And substituting the value of y200 and y10 in equation 3rd. So substituting the value of this in here, so 244 minus 109 will be 135, and K200 minus K10. K200 is Y200 minus Y1 by S1, and K10 is K200 minus K10 is 1 by S1, Y200 minus Y10, 1 by S1, 1 by Y200 minus Y10 is this minus this, so it will be Sn will go here, and we can calculate sigma n minus 1 divided by Sn as 44.3287. For the 5 years and 400 years. For the 5 years and 400 years, y5 is minus ln this 5 divided by 5 minus n, and for y400, for t400, y400 is minus ln 400 by 400 minus 1, that is 5.99, and by this formula sigma n minus 1 by Sn is 44.3287 is equal to x5 minus x10 was 109, and x200 is 244. One hundred nine. So x5 is 75.737 and x400 is 274.782. So peak distance for the return period of 400 years and 500 years are 274.782, and for 5 years it is 75.737 respectively. This question was asked in TU 2072 Kartik and 2068 Jest, and it was like 2050 chance. In 2014 chance the value was 500, and in this both this is 100, this is 550. The flood discharges for 25 and 250 years from fitted Gumbel distribution are 90 and 550 respectively. Estimate flood magnitude for 50, 500 and 1000 years by Gumbel's method analytically. So we have the formula yt is x bar plus kt sigma n minus 1. These two are constant for both case, and for 25 it is k25, and for 250 it is k250. x25 is 90 and x250 is 550. Equation second minus equation first is 550 minus 90, that is 460, and this will be common, so K50 minus K25. We know yt is minus ln t by t minus 1 minus ln for 25 it is 425, and for 250 for 25 it is 25 by 25 minus 1, for 250 it is 250 by 250 minus 1, so y25 is this and y250 is this, and kt is yt minus y1 bar divided by sn for 25 y25, and for 250 y250, and y25 is 3.198 and y250 is 5.519. Substituting K2 and K50, K25 and K250 in equation third, 450 is K250 minus K25. This minus this, 1 by Sn will be common, and minus y1 minus y1, this is minus y1 plus y1, so it will be cancelled, so remaining is minus 3.198 and sigma n minus 1. So sigma n minus 1 divided by Sn is 450 divided by this is 198.019. For written period 50, 500 and 1000 years, from this formula it is mean and standard deviation is constant and variable is this. So to calculate this, first we need to calculate this. So for 50, 500 and 1000, 50, 500 and 1000, we can calculate this. So y50 is K50 is y50 minus y1 bar divided by Sn. Y50 is 3.901, 500 is 6.213, and y1000 is 6.907. IB minus I. IB minus IV minus I. IV is this x50 and I is x25. x50 minus x25. So this x bar and this x bar will be cancelled, and remaining is this K50 sigma n minus 1 minus K25 sigma n minus 1. Sigma n minus 1 is common, so K250 minus K25, sorry, K50 minus K25. and K50 is this, and sigma n minus 1 by Sn is 198.019. So Yox 500 is this. Similarly, Bi minus I, and we give Yox 100 at 24.452 meter cube per second. In 2012, for given river, estimated flood peak of two return period 50 and 100 by use of Gumbel's method are given below. What return period T is equal to what? We'll have the discharge Yox is 59,000 meter cube per second. So we need to calculate T. So for this, Yox T is Yox bar plus YT sigma n minus 1 for first. Yox 50 is Yox bar plus K50 sigma n minus 1, and for second, Yox 100 is Yox bar plus K100 sigma n minus 1. This minus this gives Yox 100 minus Yox 50, 46300 minus 40809, that is 5491. This and this cancels, and sigma n minus will be common, and K100 minus K50. Y50 is K50 is Y50 minus Yn Sn. Similarly, K100 is Y100 minus Yn Sn. Y50 is minus ln 50 by 50 minus 1. Y100 is minus ln 100 by 100 minus 1. So B minus IB. This minus this will give K100 minus K50 is equal to 1 by Sn, 1 by Sn common, and minus Y1 bar and minus minus plus Y1 bar will cancel, and Y100 minus Y50. So Y50 is 4.60015, and Y50 is 3.9019. So from here, K100 minus K50 is this 0.69825 divided by this Sn. Now K50 minus K100 minus K50 is K100 minus K50 is this 5491 divided by sigma n minus 1, which is equal to this. From here, sigma n minus 1 divided by Sn is 5491 divided by 0.69825, which is 7864. From A, this formula, Yox T is Yox bar plus KT is YT minus Yn bar divided by Sn sigma n minus 1, and this Yox T is 59000 it's equal to x bar. X bar is this x50 minus k50 sigma n minus 1. x50 minus k50 is y50 minus yn bar sn sigma n minus 1 plus yt minus yn bar sn sigma n minus 1, and sigma n minus 1 sn will be common, which is 7864, and this minus plus yn and minus yn will also cancel, and remaining is yt minus y50 was 3.9019. So from here only yt is unknown, so yt is 6.2151, but we need to calculate t. So yt is minus ln t by t minus 1. Yt is 6.2151 minus ln t minus 1. By calculator we can get t is 500.746, so which is nearly equal to 501 years. And this is the final question which was asked in Purvanchal University 2009 chance flood frequency computation for a river by using Gumbel's method. Yielded the following result. For written period 50, discharge is this, and this discharge has written period of 100. Estimate the flood magnitude in this river with a written period of 500. So estimate the flood magnitude. So x50 is 40809, x100 is 46300. So we know this formula. For 50, kt is k50, and for 100, kt is k100. So this minus this is x100 minus x50, this minus this is 0, and this minus this sigma n minus 1 will be common, and k100 minus k50. So k100 minus k50 sigma n minus 1 will be x100 minus x50. This minus this will be 5491, which is equation 3. So we know kt is yt minus yn bar divided by sn. For t100, k100 is this, and for t50, yt will be y50, and this minus this will give k100 minus k50 is 1 by sn will get common, and this will be cancelled, and remaining is y100 minus y50. y100 is minus ln 100 by 100 minus 1, y50 is minus ln 50 by 50 minus 1, so it is this and this. Equation 3 was k100 minus k50, y100 minus y50 by sn, so this minus this by sn, sigma n minus 1, sigma n minus 1, it's equal to 5491. 5491. So from here sigma n minus 1 by sn is 7864. We need to calculate the discharge for written period of 500 for T500. For T500, Y500 is minus ln 500 by 500 minus 1, which is this, and By rearranging above equation, we get this. So y500 is this, and y100 is y100 4.60015, and this is 7864. X500 we need to calculate, and X100 is 46300. So for return period of 500, the discharge is 59000. So this much for today. If you like the video, hit that like button and share it with your friend, and finally subscribe the channel. Thank you.